Next, let me describe the uncertainty measure called the entropy for the distribution. So suppose you went to casino and play some dice rolling game. So dice has the face value from 1 to 6, right? And then we usually don't know which one to come out, right? So you want to bet your money into a particular value. And if your dice is getting that value, that you bet your money on, and then you will earn your money twice. Okay, so in this case, if the dice has the probability as this, for the face value ranging from 1 through 6, with the all equal amount of probability, and then it can be viewed as the case of having maximum uncertainty, right? And then what about a dice that is kind of specially designed in a way that it will always produce the value of 6, right? So in this case, the probability distribution can be like this, and in this case, we can view the uncertainty as completely 0, right? Max value. So how can we mathematically define this uncertainty in a quantitative manner? And that quantitative definition of this uncertainty is called this entropy, and that entropy is defined as follows. Okay, so in this case, I will be starting from 1 through 6, and then let's consider this case first, and then in this case it will be defined like this. Okay, so bringing negative into inside of the log, and then it will become 6, right? And then like 1 over 6 times 6 will be just 1, and thus it will have log 6, and that can be viewed as this maximum value of this uncertainty that this dice can have. Okay, but what about this case? Let's just compute this measure once again for this case. In this case, 1 through 6, then, but in this case, all the PIs are 0 except for the last one. Okay, and then if we consider the last one only, then minus, and the probability will be 1, and then log 1, and log 1 will be 0, right? And then it will be 0, right? And thus we achieve the uncertainty value as 0, right? And then if our dice value has maybe and maybe like this, so 1 6 1 6, and then maybe 0. Okay, in this case the uncertainty is less than this case, but the uncertainty is clearly more than the case where we had the probability only assigned to the face value of 6, right? In that case, the uncertainty value will be somewhere around 0 and log 6, right? So this entropy will give you a convenient way to measure this uncertainty in a quantitative measure. In a quantitative way. And then if we have the face value as just two kinds, maybe head and tail of a coin, and then our maximum uncertain case will be like this. And then in this case, if we compute this entropy value, and then it will have this value. And then the face value, head has the 0 probability, and tail has maybe the probability of all 1, and then similarly it will have 0 uncertainty.